Good morning. Today I will be doing two questions of the question paper Pearson Edexcel. Okay, level 3 GCE, the question paper which we were doing. Okay, the two questions today we will be doing. Okay, question number 9 and 10. Okay, the up to 8 we have already done. Now 9 and 10 today I will do. Otherwise, the question, this video will become very large. Okay, today only two questions I will be doing. Okay, now please follow here. Understand? Okay, let this page open. Then I am continuing. Okay, 1 second. Let this page open. Then I am continuing. Okay, 1 second. This is the question number 9. Given that theta is measured in, okay, theta is given that theta is measured in radians. Prove that, prove from first principle that the derivative of sine theta is cos theta. You may assume the formula for sine A plus minus B, and that as h tends to 0, sine h by h value tends to 1, and cos h minus 1 divided by h tends to 0. Okay, so from the first principle, we have to show that the derivative of sine theta value is cos theta. Using these formulae, sine A plus B minus A plus minus B, and as h tends to 0, sine h by h tends to 1, and cos h minus 1 divided by h tends to 0. Okay, so I am doing it. Now you please follow here. Okay, I am doing this sum. So here the you may write fx or y value is given is equal to sine x. Okay, sine x. Okay, so dy by dx by the first principle, the formula is limit of h tends to 0 f x plus h minus fx whole divided by h. This is the formula for the derivative of any function from first principle. Okay, so here we are given the fx value is sine x. So what will be the value of fx plus h? So in place of x, you will write x plus h. So fx plus h value will become sine x plus h minus fx value will be, in place of x, you will just write x, which is sine x, whole divided by h. Now the sine, we know the formula of sine A plus B formula is what? The sine A plus B formula is sine A cos B and plus cos A and sine B. Okay, now here in this case, x plus h is there. So in place of A it is x and in place of B it is h. So use that formula. In place of A you write x. So sine x plus h value will be sine x times cos h and plus cos x times sine h minus sine x whole divided by h. Okay, now what we are doing, we will take the sine x common from these two terms. Okay, so this become h tends to 0, sine x I am taking common from these two. Okay, so what I will get in the bracket, cos h minus 1 after taking sine x common from the first term and the last term. And the middle term you write separately, cos h times sine h whole divided by h. Okay, so now you separate these two. Okay, we are uh, doing this separately. So this becomes sine times sine x. Sorry, this is sine x. Sorry, sine x is taken common. Sine x times cos h minus 1 whole divided by h. And this we write separately. Limit of h tends to 0, cos h times sine h whole divided by h. Now this sine x, okay, you write it before the limit. Okay, because there is no h, we write it sine x. Okay, limit of h tends to 0 of cos h minus 1 divided by h. And from here you take out the cos x out. Okay, this will become cos x times limit of h tends to 0 sine h upon h. So in the question we are already given this formula. As h tends to 0, sine h by h value is 1 and cos h minus 1 upon h tends to 0. So here you put these values which are given in the question. So sine x and this value, limit of h tends to 0, cos h minus 1 upon h is told to us the limit of this is 0. So put here limit of this 0. And this is cos x and the limit of sine h by h is given in the question. Its value is 1. So we are putting here value 1. So sine x times 0, 0 multiplied with any term or any, okay, number, value is 0. And cos x multiplied with 1, 1 multiplied with any term, we get the same term back. So here it is cos x. So that was asked to prove that the derivative of the sine x by first principle, you have to show the derivative of sine x is cos x. We have showed it. Okay, now we are moving to the last question of today's class. Okay, an archer shoots an arrow. The height h meters of the arrow above the ground is modeled by the formula h is equals to 1.8 plus 0.4d minus 0.002d squared, where d value is greater or equals to 0. That is not negative value. D value is not negative. It is either 0 or more than 0. Where d is the horizontal distance. D represents the horizontal distance of the arrow from the archer measured in meters. So D represents the horizontal distance of the arrow from the archer in meters. Given that the arrow travels in the vertical plane, so arrow is traveling in the vertical plane until it is hitting the ground. Okay, so it flies in the vertical plane and then it hits the ground. Okay, now we have to do these things. A, B, C, and D, there are four parts of this question. D, there are two parts. A, B, and C, there is single part. So in the A part, it is asking, find the horizontal distance traveled by the arrow as given by this model. How much distance is the horizontal distance? How much horizontal distance the arrow is traveling? Okay, before hitting the ground. That is the part A. And in B, we are asked, with reference to the model, interpret the significance of the constant 1.8 in this formula. So in the formula, we are given some constant number 1.8. Asking what is the significance of this constant number 1.8. Okay, that is B part. In the C part, it is asking write 1.8 plus 0.4d minus 0.002d squared in this form. You have to change this, okay, expression. What is given? 1.8 plus 0.4d minus 0.002d squared in this form. You have to change this expression in this form. A minus b times d minus c whole squared, where we are told a, b, and c are some constant numbers, which we have to find the values of a, b, and c in this formula. Okay, it is now that is the C part completed. Now we are moving to the D part. It is decided that the model should be adapted for a different archer. Now, the same model, we are adapting it for another archer. Now, the adapted formula for this archer. Now, adapted formula for the new archer is H value is 2.1 plus 0.4d minus 0.002d squared, and d value is greater or equals to 0. That means in the place of this constant number, in the earlier model, the constant number was 1.8. In this adapted model, the constant number is changed to 2.1, and other terms are just as same as the previous what model is given. 0.4d, here it is also 0.4d plus and minus 0.002d squared, and d value is greater or equals to 0. The same thing is here, minus 0.002 d squared, where d value is greater than 0. Okay, 0.002 d squared, where d value is greater than 0. Hence or otherwise find for this adapted model. Now for this adapted model for the another archer. Okay, there are two parts of D. First part, the maximum height of the arrow above the ground. What is the maximum height reached of the arrow? You have to find out that thing. Above the ground, how much is the maximum height reached? The second part, the horizontal distance from the archer of the arrow when it is at the maximum height. It is asking at what distance the horizontal distance. What is the horizontal distance of the arrow from the archer when the arrow is at the maximum height? Okay, now we are doing this sum. Okay, now you follow here. See here. When we throw anything from the ground, okay, it travels in this, okay, type of path, parabola. This path is called parabola. Okay, now from here the arrow flies. This is the some height, initial height above the ground. Okay, and it reaches the ground, okay, touches the ground at some point, and this is the maximum height reached, and this distance traveled is called d. Okay, horizontal distance, and this is the, okay, the maximum height reached. Okay, maximum height which is at the vertex. Okay, the maximum height. This is how the arrow flies when we shoot it, the arrow. Okay, now we are doing the question. Okay, A part. Okay, now A part is asking find the horizontal distance traveled by the arrow as given by this model. So what is given in the model? So in the model it is given h value is given. The height traveled by the h is the vertical height. It is 1.8 plus 0.4d minus 8.1.8, okay, plus 0.4d minus 0.002d squared. Okay, this is the model in which the arrow is traveling 0.002 d squared, where d is the horizontal distance traveling from the archer. Okay, and h is what? Capital H. Okay, h is the height which the arrow is above the ground. Okay, at any point, any moment. So a part, find the horizontal distance. You have to find in the a part how much horizontal distance the arrow is traveling. Okay, as given by this model, that means before hitting the ground, how much horizontal distance the arrow is traveling. Now see here, the a part I am doing. Now when the arrow travels, the when the arrow hits the ground, okay, at that moment, suppose the horizontal distance, now here is the point where the arrow is hitting the ground. So that distance is asked how much distance it has traveled. The arrow has traveled before hitting the ground from the archer. So when the arrow hits the ground, at that moment, the h is 0. So the vertical height of the arrow from the ground is 0 when the arrow hits the ground. So in the place of capital H, you put 0. So therefore, putting, okay, putting capital H value is 0 in the above model, in the above equation. In the above model or equation, you may write. So in the place of H, we will put 0, because when the arrow hits the ground, that how much at that point where the arrow is hitting the ground, what is the distance traveled, horizontal distance traveled by the arrow at that point? That is the question. Find the horizontal distance traveled by the arrow, that means before hitting the ground. Okay, when it hits the ground, then what is the horizontal distance the arrow has traveled? So when the arrow hits the ground, the vertical height at that point is 0. So put the h value 0 and solve this equation. So we get here 0 is equals to 1.8 plus 0.4d minus 0.002 d squared. Okay, and d value is greater or equals to 0. If on solving this equation, see, this is a quadratic equation in terms of d. So on solving a quadratic equation, we get two values of d. So one value may be negative and other may be positive, or one both will be positive, or uh, both will be negative. Okay, we will check what are the values of d, and then we will think which value of d is accepted and which value of d is neglected. Okay, we are bringing all the terms from the right side of the equal sign onto the left side. So minus this term, we write d squared value term first. Okay, minus traveling to the left will become positive. Okay, and then I am writing the d term 0.4d, plus coming to the left will become minus, and then plus 1.8 coming to the left will be minus 1.8. Value is equals to 0. Now this is the quadratic equation. Okay, now either you may solve this directly or you may remove the decimal point from all the coefficient. Okay, we are doing directly. So here the d value is asked. That is the horizontal distance. So we will use this formula. Minus b plus minus square root of b squared minus 4ac whole divided by 2a. This is the formula of getting the values of the variable here, okay, by this formula. Okay, so I am using here B denotes the coefficient of D, and A denotes the coefficient of D squared, and C denotes the constant number. So here A is equals to the coefficient of D squared, which is 0.002 positive value, and the B denotes the coefficient of D, which is minus 0.4, and C denotes the constant number that is free from D, which is minus 1.8. In this formula, you put the values of A, B, and C and solve it, you will get the value of D, which is the answer. So it is minus B value. B value is given in the question minus 0.4. So put that value here. Plus minus the square root of this B squared. That is minus 0.4 whole squared, and minus 4 times A. A value is 0.002 times C, multiply with the value of C, which is minus 1.8. Now use divided by 2A. So divided by 2 times A value. A value is 0.002. Now you, okay, calculate and get the value of D. So this is only simply now calculation. Minus time minus 0.4 will become plus 0.4, and plus minus, okay, now do the calculation. Okay, now we are using here calculator value. Okay, calculator I am using for doing this working. Okay, so here we have to square zero point 0.4. Whether you square a negative number or whether you square a positive number, the answer is always positive. So square of minus 0.04, the answer is 0.16 plus, and minus times minus become plus. So you multiply all these numbers. Okay, answer will be positive because negative multiplied with negative is positive. 4 multiplied with 0.002, then you further multiply it with 1.8. So this number comes to 0.0144 whole divided by multiplied 2 multiplied with 0.002, which is 0.004. Now you do the calculation. Okay, now you do the calculation and get the value of D. So this is 0.4 plus and minus. Okay, you add up these two numbers. So let us add up. So this is 0.0144 plus 0.16. So this comes to 0.1744 whole divided by 0.004. Now you find the value of this square root. So the D value is 0.4 plus and minus. So we are doing the square root of finding the square root of this number. Okay, the square root of 0.1744. So this I am writing in, okay, it's a third place I am first writing. Okay, fourth place I am writing, then we will round up it to the third place. Okay, after the decimal point. So the fourth digit after the decimal point is 4176. Fourth digit is 6. This is not a last digit of the decimal. Okay, point. Decimal part 6 is not the ending. So we will round up. Okay, because this is continuing without any ending. 0.004. Now see here. So the here what we get, D values are here, we are putting 0.4 plus 0.4176 whole divided by 0.004 or the D value is 0.4 minus 0.4176, either plus or minus, divided by 0.004. So you solve, and what are the values of D you find out. So D is coming here in the first. It is 0.8176 divided by 0.004. And from the second, what we are getting, okay, negative number 0.0176 whole divided by 0.004. So this is coming a negative number. So this is neglected. Why? Because we are told in the question the value of D is either greater or equal to 0. Either it is greater than 0 or it is equal to 0, not a negative number. So in the second, okay, here we are getting a negative number of value of D. So this is neglected. Okay, this is neglected. Okay, so this is neglected. Only this value of D will be accepted. So divide here. Okay, 0.08. Okay, here it is 0.8176 divided by 0.004. So this number comes to 204.4. So many meters is the distance, horizontal distance traveled by the arrow before hitting the ground. Okay, that is the A part answer. Now we are moving to the B part. Okay, now you watch. So what is the A part is done. Now we are moving to the B part. With reference to the model, interpret the significance of the constant number 1.8 in this formula. Okay, now see here. In this formula, the we are told the height of the arrow at any point is given by this model 1.8 plus 0.4 times D minus 0.002 D square. Okay, let us check. Okay, it is here 1.8 plus 0.4 D. 1.8 plus 0.4 D, okay, minus 0.002 D squared minus 0.002 D squared, where D value is greater or equals to 0. So what is the significance of this constant number in this formula? That is asked. Now see here. If we are putting, see, I told you earlier, in the, I told you, when the arrow flies, okay, when the archer shoots the arrow, okay, from the bow, the arrow travels in this, okay, path. This is path is called parabola. In this parabolic path, the arrow travels. So D represents the horizontal distance traveled by the arrow. Okay. Now see here, when in this formula, the H value is given to us this. In this formula, if I put the value of D 0, okay, D value 0, that means when the horizontal distance is 0, that means the arrow has not traveled, okay, any distance horizontally. That means when the arrow has not traveled any distance horizontally means what? The arrow is at the initial point of when the arrow has just shot at that point. That means the time is 0, the arrow has not traveled any horizontal distance. So putting the D value 0. So putting D value 0 in the above formula, in the above formula, what we get? Now when the value we are putting 0, that means the arrow has not traveled any horizontal distance. So in this formula, you write the value of D 0 and simplify it. So 4 times 0.4 times the value of d is 0 minus 0.002 in the place of d you write 0 whole squared. Okay, now because d value is either 0 or greater than 0, not less than 0, that means when the d value is 0, the it is not traveled any horizontal distance, that means at the starting point. Okay, that means just at the moment when the arrow is short. So here h value becomes what, 1.8, and 0 multiplied with any number we get 0. 0 squared value is 0 and 0 multiplied with any number is 0. Whether you add 0 or subtract 0, same thing. So 1.8 is the answer. So h value is 1.8. So what is the significance of this number 1.8? It represents the initial height of the arrow. That means at the moment when the arrow is just short. So the constant number 1.8. So 1.8 represent the initial height of the arrow, represent the initial height, the initial height of the arrow. That means at the moment when the arrow was shot. So that is the significance of this constant number 1.8. Okay, so B part is done. Now we are moving to the C part. So the B part we have completed. Now we are moving to the C part. Okay, now what is the C part saying? Write 1.8 plus 0.4d minus 0.002d squared in this form of expression a minus b times d minus c whole squared. Here the d is same d which is given in the formula. That d, okay, a, b, and c are some constant out. So we have to change the given formula in that form. Okay. Now I am writing we are doing the C part. Here the we are asked change this 1.8. So this is the expression given in the question. So 1.8 plus 0.4d minus 0.002 d squared. Okay, this we have to change this expression. Okay, in the form of this type of okay, some expression of this type, a plus b times d minus c whole squared. Okay, of this type of expression we have to change this given expression where where a, B, and C, where A, B, and C are constant numbers, are constants, are constants, okay, to be found out, to be found, okay. You have to find the values of A, B, and C, change this expression in this form, okay. Now we are doing it. See here. Now, how we will change the given expression in this type of form? Okay. Now, you please watch. So, this, see here, understand. In this, okay, the transformed, okay, expression, it is d, okay, d minus some number whole square. So, this we will change to a square form, the expression of d. Okay. Now see what we are doing. I am writing 1.8 constant number separately. And from this two terms, 0.4d and minus 0.002d square, I am taking the negative sign out because this term you have to make positive d square term inside the bracket. So take the negative sign common and this 0 point. So when I take the negative sign common out, so this term, negative term will become positive. 0.002 d square, and the positive term will become negative. Okay, minus 0.4d, and this number 1.8 we have written separately. Okay, now for changing this okay expression d squared and d in this form, d minus c whole squared. So you take out, make the coefficient of d squared positive 1. So we have to here, okay, first what we are doing, okay, you make the coefficient of d squared positive number. So, sorry, positive 1. So, make the coefficient of d squared positive 1. So, take this common out. So, we are taking 0.002 out from here, common out. So, the coefficient of d squared will become positive 1. That is necessary to make the coefficient of d squared negative, oh sorry, positive 1. So I have taken that common. So you have to divide the minus 0.4d with this number 0.002. So when you divide here, see here, 0.4, when we divide here, we have to divide that constant number by 0.002. So move the decimal point 3 places right on the top and down. So now you divide. So 300 divided by 2 will be become 200. So you will get here 200d. Okay. Now you change it to this form, d minus c whole squared form. Okay. So it is 1.8 minus 0.002. Here we are changing it. Okay, in that form. So you will be using this formula. See here. A minus b whole squared formula is what? A squared minus 2ab plus b squared. This is the formula of expansion of a minus b whole squared. So we will change it to this type of expression. So write d whole squared and take 2 common because the middle term is 2 times ab. 2 common out from 200. 200 you divide with 2. And write this d first, the first term d which is written within the bracket, d whole square. So that you write and divide 200 d by 2d, and the answer you write here 100. So the product of 2d times 100 is 200d. So in this formula the b value is 100. So we have to add plus 100 whole square for changing it to the square form. So we have added 100 square, but there is no 100 square here. So we have added 100 square just to change it to the square form. So after adding 100 square, to make it equal, you have to subtract 100 squared also. Okay, then it will become added and subtracted. The result will be same as what is on the top line. Now you simplify it. So this become 1.8 minus 0.002 times. Now these three terms, first three terms, okay, we can write it like this: d minus 100 whole squared. So this become d minus 100 whole square, d squared minus 2 times d multiplied with 100 plus 100 whole square can be written in this form: d minus 100 whole square. And here it is minus 100 whole square. So when we square 100, you write 1, and after 100 there, after 1, in the 100 there are 2 zeros. So on squaring, you will get 4 zeros. Okay. So now you simplify it further. Okay. So we are now simplifying it. So this become 1.8. Multiply this number 0.002 with both the expressions, both the terms inside the box bracket. So this become minus 0.002 times d minus 100 whole square, and minus 0.002 you will multiply with, okay, 10,000. So negative multiplied with negative value become positive. So when you multiply this number 0.002 with 10,000. Okay, 1 and 4 zeros. So this decimal point will be shifted 4 places to the right, and these 4 zeros will be cut out. So this number will become 20. So minus 0.002 multiplied with minus 10,000, you will get plus 20. Okay, now you simplify it. So 1.8 and 220 you add up. Constant numbers, that is free from any variable. 1.8 plus 20 gives us 21.8 minus 0.002 times t minus 100 whole square. So we have transformed it to this. Okay, what was asked in the question? It was asked to transform that in this form of expression. A plus b times d minus c whole square. This type of expression it was asked to transform that expression. A, B, and C are some constant numbers. Okay. Now you A, B, and C are some constant numbers. Constant numbers are constant numbers. Okay. Constant numbers. Now you here what you do? You okay compare this. The A plus B D in bracket D minus C whole square with this expression. On comparing what we get, the here A value is, so A is 221.8 and B value is here. Okay, on comparison, okay, B value will become minus 0.002 and the C value is here. On comparing, we get C value is 100. So we have transformed it into this form. And A, B, and C are these values. Okay, so C is done. So C part we have completed. Now the last part we will do now. Now the C part is already done. Okay, now we are moving to the last part, D. D has two parts, 1 and 2. The D first part here it is asking. Okay, here it was told to us that for a it is decided that the model should be adapted for a different archer. So the previous model we have transformed it to a new type of model. Only the constant number, earlier it was 1.8, it has been changed to 2.1 for a some new archer. Hence or otherwise find for the adapted model. So this is the new model for a new archer. So we have to find for D the maximum height of the arrow which is reached above the ground. What is the maximum height for this new okay model? So we are writing the new model. So the part D is for the new model for a new archer. So this is the adapted model. So the adapted model, so the adapted model for a new archer, for a new archer is what? So the adapted model for the new archer is H value is here. H is equal to 2.1. Earlier the constant number was 1.8. Here it is 2.1 plus 0.4D minus 0.002 D squared. And D value is told to us is greater or equals to 0. We are asked in the first part, what is the maximum height reached for the new archer? For the new archer, what is the maximum height above the ground? So here we have to find this point, this distance, height above the ground, maximum height. Okay, now see here, how we find out the maximum height. So in the first part, it is asked, find the maximum height reached by the arrow above the ground. So you differentiate this equation, okay, with respect to D. So differentiating with respect to D on both the sides, on both sides of the above model, on both sides of above equation, Okay. Now what you do, you differentiate both the sides with respect to this d. Okay, with respect to d. So dh upon dd value is constant number differentiating, we get 0, and 0.4d. So this on differentiation we get 0.4, and on differentiating the last term, this power 2 will come at the bottom and multiply with 0.002. So 0.002 multiplied with 2 gives us 0.004, and d power will reduce by 1. So that is the first differential coefficient of h with respect to d. So for the maximum height, we have to equate this to 0. For finding the maximum height, this value has to be equated to 0. So you solve this and find out the value of d. So this equation we are solving, minus 0.004 d plus 0.4, you move other side. It will become minus 0.4. Now you cancel the negative sign from both the sides. Now you find out the value of d. So this constant number which is multiplied with d, the coefficient of d, we will move other side. It will change to divide. So 0.4 divided by 0.004. Okay, shift the decimal point to four, three places to the right in the numerator and denominator. Okay, add two zeros in the numerator. So this becomes 400 divided by 4. So the horizontal distance become d value is coming to 400 divided by 4 is 100. Now we have to check that whether at this value of d is the maximum height reached or not. So when the arrow has traveled this d 100 meters, okay, when the arrow has traveled this distance 100 meters, that is this height which is reached by the arrow is the maximum height or not. We have to check it. Okay. Now for that, what is the way of checking? uh, we have to find the second differential coefficient of this h with respect to d. So this, okay, expression d dh upon dd, you will differentiate again. You will get the second differential coefficient of d. So this I am writing, suppose, equation number 1. Differentiate this one again with d on both the sides. Okay. Now differentiate. So differentiating with respect to d, with respect to d on both sides, on both sides of equation number 1. So what we get? We get here d squared h by dd squared. Value is here the constant number 0.4. So its differential coefficient will be 0. And of minus 0.004d will be minus 0.004. Okay, d will be eliminated. D will not be written. Just the number which is written before d, that is minus 0.004. So this comes to 0 minus 0.004 is minus 0.004. So here, when we are putting the value of d in this expression, there is no d here. So the value of d squared, so the value of d squared h, uh, d squared h upon d squared, when the d value is 100. What is the value of this? This is coming to negative number, minus 0.004, which is less than 0. So when for if the value of d squared, the second differential coefficient, if the value of the second differential coefficient is 0 for this value of d, then it means that the height is maximum when the d value is 100. So therefore it means the maximum 100 meters. Okay, now in this, okay, model, in this model, which is given the model of h, okay, for different values of d, there are different heights of the arrow. So the maximum height of h will be for the d value 100. So in this formula, you write the value of d 100, that it will be the maximum height reached. So the d value is 100, the maximum height. So putting d equals to 100 in the above model, in the above model. So the h value will be maximum in this case when the d value is 100. So it is 1.8 plus, okay, is 1.8 plus, okay, what? Oh, not 1.8, sorry, 2.1. Sorry, for the new model, it is 2.1. Sorry. So it is 2.1. So right here, 2.1. Okay. It is 2.1. Okay. 2.1. Okay. Plus 0.4D. So plus 0.4D minus 0.002 d squared, and d value is greater or equals to 0. That is the given model. So in this model, you will put the value of d 100. So what, on solving, what value of h we will get, that will be the maximum height. So here 2.1, and in place of d you write here 100, 0.4 multiplied with 100 minus 0.002 multiplied with d squared. D value is 100. So in place of d you write, okay, I have to here refresh it. 1 second. Okay, my pen has stopped writing. So I have to refresh it. 1 second. Okay, 1 second, it is refreshing. Okay, then we are able to do. Otherwise, my pen will not work. Okay, 1 second. It is refreshing, and then we will continue. Okay, it has refreshed. Now I am continuing. Okay, so my pen has, this is refreshed, my pen has refreshed. Now I am writing here. So in the place of d you write 100. So and solve, and you will, what value of h you will get, that will be the maximum height. So now we are solving it. This is 2.1, 0.4 multiplied with 100. So shift the decimal point 2 places to the right. This will become 40. And here you simplify here. 0.002 times 100 whole squared value is 10,000. So here you shift the decimal point 4 places to the right. So here h is equals to 2.1 plus 40 and minus. So here when we shift the decimal point 4 places to the right, we will get here 20. 40 minus 20 is 20. So this is 2.1. From 40 you subtract 20, you get 20. So the maximum height reached is 22.1 meters. That is the maximum height reached by the arrow. So the maximum height reached by the arrow is, so maximum height reached. So the maximum height reached by the arrow, reached, okay, REACHED, reached by the arrow, by the arrow is equal to 22.1 meter. That is the answer of the first part. Now we are doing the D second part. This was the D first part. Now what is asking in the D second part? In the D second part, it first part is done. In the D second part, distance from the archer when it is at the maximum height. What is asking? We have already found out. It is asking what is the horizontal distance of the arrow from the archer when the arrow has reached the maximum height. So that distance we have already found out, d. So when the arrow is at the maximum height, the horizontal distance of the arrow is this 100 meters, which we have already calculated. So that is the answer of the second part. We have already calculated that. So D value is 100 when the maximum height is reached. So that is the answer of the second part. It is asking what is the horizontal distance of the arrow traveling. What is the traveled when the arrow has reached the maximum vertical height? So the horizontal distance traveled. So horizontal, horizontal distance traveled. So the horizontal distance traveled, okay, when the arrow has reached the maximum height is here 100 meters. So that is the answer of the second part of D. I hope you must have understood this question, all the sums which I have done here. Okay, more of these questions we will be doing in the other classes. Okay, have a very nice day. Okay, okay, bye. Okay, bye.